All right, let's actually use elasticity of demand. We've got an example here of a company selling ribbon winders, and they sell them for P dollars each. And we have a demand equation that's linear like so. Again, the more we want to sell, the lower the price has to be. This is a line with a negative slope. Find the elasticity of demand at a certain price point. Okay, so now I said ignore the formula, but now we need the formula. Elasticity of demand is the absolute value of P over Q times dQ dP. And remember what this means. Is it really dQ dP? Yeah, it is. Well, that's going to be annoying. Okay, so we need to use this formula. So first off, the absolute values are there because this derivative is always going to be negative, right? Because this is the derivative of Q with respect to P. That means how does Q change when P is increased? And the quantity will always go down as the price goes up. So this will always be negative, and people like dealing with positive numbers. That's the only reason why there's an absolute value here. Just a little easier to work with positive numbers. Okay, so we need the derivative of Q with respect to P. Unfortunately, this isn't really solved for Q. And so you can either solve for Q, or you can either just take the derivative with respect to P of both sides. But that's kind of getting into a more complicated topic that we didn't really cover. So let's solve for Q. We're solving for Q so we can find dQ dP. There are simpler ways of doing this that, well, there's simpler steps, but they're more confusing processes. This is probably the most straightforward. All right, so let's solve for Q. We need the Q by itself. Let's add 0.02. Actually, let's just subtract 300 from both sides. When we do that, we get P minus 300 equals negative 0.02 Q. Divide by negative 0.02. And we'll get Q equals that whole monster, which will be negative 50p plus 15,000, I think. Dangerous decision to do this in my head. What do we got here? 300 divided by 0.02. 15,000. Great. Okay, so now we can find dQ dP. We take the derivative of Q with respect to P. And that's just going to be negative 50. Okay, so that's one thing that we need, right? We know this is negative 50. We know the price is 70. So we have that. All that's left is finding out what the demand is, and then we can plug everything in. Right? We're trying to find E. We know P is 70. We don't know Q yet. Let's leave that blank. And we know the derivative of Q with respect to P is negative 50. So we're almost done. So when P equals 70, what's Q? You can use either one of these. We already solved for Q, so using the bottom one's a little easier. Q is negative 50. Whoa, dear. Oh, dear, we got an issue here. That's supposed to be a P. Mind your P's and Q's. All right, so Q is negative 50 times P, which is 70 here, plus 15,000. That tells us that Q is 11,500 or something. I don't know. It's negative 50 times 70 plus 15,000. I'm on fire today. I need to trust. No, I'm not going to trust myself. 11,500. So if we charge $70, we can sell 11,500 of these items. All right, so our elasticity of demand, and again, I said this is always going to be negative. You can see it's negative here. Plug that all in. Oh, I dropped my pen. 70 times negative 50. Absolute value, 70 times negative 50, all over 11,500. Yep. That's about 0.30. Let's just round it to 0.30. Approximately. All right. That's the elasticity of demand. All right. I'm pretty sure this is a unitless quantity, but I actually haven't thought about it, and I'm not going to because that'll take a while. This is our elasticity of demand right now. That's all the problem wants you to do. Use the formula. What is the derivative of Q with respect to P? What is your price? What is your quantity? Plug it all in. There you go. The more interesting thing is interpreting the value in the context of the problem. All right, so what did elasticity of demand mean? This right here is the most important part of the definition. A price increase of 1% means a demand decrease by E%. So this says that at a production level, because it does matter, at a production level, or at a, not a production level, right? At a current price of $70 per item, increasing price, and usually we this quarter we've usually been focusing on production levels. This section we really do focus on the price. Again, there's no one size fits all. You can do either. It's not really like one's an input, one's an output. It just depends on perspective. They're both fine. But I am noticing now that, yeah, we usually have been focusing on production levels, but now we're focusing on prices. But at a current price of $70 per item, increasing price by 1% results in a decrease of demand by, and we can type all of these words without part A. Okay. You don't need to, let's say you're taking a quiz or something. You don't know the elasticity of demand, but you have the definitions. I don't know how that would work, but let's say you can get through almost the entire sentence. And then the last thing is just E%. So this percent, 0.3%. And that's just the definition right here. At our current price, if we increase price by 1%, demand will decrease by E%. Increasing price by 1%, decrease of demand by E%. E was 0.3. And this part right here is very important. Oh gosh. This part right here is very important because it does depend on where you are. So, don't page back. No cheating. It's not cheating, it's using your notes. But let's try to use this answer to answer C. Will an increase in price lead to an increase in revenue? What do you think? Increasing price by 1% means the demand decreases by only a little bit. Price will increase faster than the demand will decrease. So us, being the ones to sell things, price increasing is good. Demand increasing is bad. Price increase is bigger than demand decrease. That's going to be good for us. We want to increase production. Yes. We have E is less than 1. We have inelastic. Increasing price increases revenue. All right, we are inelastic right here. There we go. And visually, we could see this if we actually plotted a revenue function. Okay. Revenue is price times quantity. So let's put it in terms of price. Revenue is price times negative 50p plus 15,000. And again, we're going to have to zoom out a bit. Okay. All right. This is getting silly. Let's see. Let's just go to 300. You can see where we're at. We're at a price of $70. And yeah, we said increasing price increases revenue. You can see that very clearly on this revenue function. Increasing price will increase our revenue. And you could find all sorts of elasticities of demands. At any price point over here, you're going to get inelastic. Any price point over here, your E is going to be less than 1. Any of these prices, we're going to be told to increase production. Here's where our elasticity of demand would be unitary, which would be at a critical point of the revenue function. And pick any point over here, and your elasticity of demand will be bigger than 1. We'll have elastic demand. Don't believe me? Pick some of these numbers. Any number to the right of here will have an E value bigger than 1. Any value to the left will have an E value less than 1. Try it out. Let me know if you have any questions, but I think that is almost done. Yeah, it is done. Great. Bye-bye.